Hi, this is Marvin from High Chair Strength and Conditioning, and this is BROSCIENCE Part 3. We are going to learn about human movement and how this human movement come about. We are going to learn about physics of levers. There are 3 types of levers, and we are going to explain one by one and give an example of human movement using those levers. To some people, this might be a little bit dry, and I know that the video will be a little bit long, so bear with me, it's going to be interesting. So let's start with class 1 lever. Let's start with the most basic type of lever. This is the first class lever. The first class lever has a center of rotation, or the fulcrum, right in the middle. We have the load on one end, and the force applied will be on the other end. Now, the weight over here is 10 grams. So I have this type of weight, each is 5 grams. I'm going to put 2 of them together like this, and then I will put it on the other end, and then we will see what happens. Okay, yep, okay, so let me just try to, okay, you can see that it is now balanced because the weight over here is 10 grams, the weight over here is also 10 grams, and the other thing is that the moment arm between the fulcrum to this end and the fulcrum to that end is exactly the same. That's why it is balanced. So the moment force generated by this end and this end is equal. So in the model that we've seen, there are 2 components that were mentioned: the weight and the length of the moment arm. These 2 important components affect how much moment force you can generate around the fulcrum. So now imagine a class 1 lever where you have a very heavy load on a certain distance from the fulcrum. On the other side, you have a much longer moment arm, a much longer lever, and you can apply less amount of force to lift this heavy weight up. This is the understanding of mechanical efficiency. If you can generate a lot of moment force with just a small amount of effort, you have a big mechanical efficiency. Whereas sometimes it is the opposite. You need to exert a lot of effort in order for you to counter a small amount of load. So this is a very low mechanical efficiency system. Let's try to see an example of a class 1 lever with differing moment arm length. Now, after trying to adjust it for a few minutes, I managed to extend the segment on the right side of the fulcrum over here, so it becomes really long. The weight over here is still 10 grams. Now I'm going to put just 5 grams of weight at the other end of the segment. Oops, over here, and then let's see what happens. Right? Although this is only 5 grams, because the moment arm is really long, this will create more moment force as compared to this towards the fulcrum. That's why now it goes down. The real life example of a class 1 lever is our body when we are doing a deadlift. This model tried to represent some of our body segment while doing it. We have our back and our hip joint over here. We have the barbell hanging on our arms, connected at the shoulder joint, and this portion over here represents our leg, especially the femur. The most important portion or segment that we want to see is the back and the hip over here. We have our fulcrum for our lever at our hip joint represented over here. And we have our load hanging on the arms, and the point of loading will be at our shoulder joint. Now, the point of effort is actually going to be the origin of the hip extensors, especially the hamstrings and the adductors. It starts at the sit bone or the ischial tuberosity, and it attaches down here at the femur, also at the tibia and fibula. So if you see over here, this is the point of effort, the fulcrum is over here, and the point of load is on the other side. This is a class 1 lever. When the muscle contracts, it pulls at the point of effort across the fulcrum, and it will raise the load up all the way as we are standing up on a deadlift. This is a class 2 lever. A class 2 lever is a lever class where the fulcrum is at one end. You have the load in the middle, and the effort or the force applied will be at the other end of the segment. So I'm going to just put this piece up. This signifies the effort that I'm going to put. So if I'm not putting any effort, of course the segment will drop down that way, right? So in order for me to lift the load up, in this case I'm applying the force at the other end of the segment, at the total opposite of the fulcrum itself. Now, this class of lever is the most uncommon one in human motion, but I have a quite a cool example for you. Can you recognize what is this? This is signifying our legs, this is our shin, and this is our foot. The load over here is the representation of our body weight. So if we are standing still, for example, and we would want to start walking, initially the load is going to be at the center of the foot, and then the center of rotation will be at the end of the foot. The effort that we do is done by the gastrocs over here, pulled by the Achilles tendon. So basically when it contracts, it does this. Okay, coming back to this model of our leg, right? I want to actually illustrate that our movement might not be purely of one class. Like for example, just now we explained that this is class 2 lever, right? If we observe that the rotation point is at the toes over here, the weight is at the center of the mass, right in the middle of the foot, and the force application is right behind over here. But if we see in detail, we can also think the ankle joint as a center of rotation, right? And this is where the force is applied, and the load is either on the toes or in the middle of the foot. No matter how you observe it, the load is on the other end of the segment. So this is also almost like a class 1 lever. So it's a class 1 lever and a class 2 lever at the same time. Interesting, right? So this is an example of a class 3 lever. A class 3 lever has a fulcrum on one end, and the load will be on the other end. The effort will be given right at the center. So if I can just use this stick as an effort, I'm going to pull this stick up, and in this case the load will also come up because of this movement. So this is a class 3 lever. The class 3 lever is probably the most common one that we can find in our body. So I'm creating this model. Let's just assume that this is our body, this is our upper arm, this is our lower arm, and you're holding on to a dumbbell over here. So this motion looks familiar, right? It is. We are trying to do a bicep curl. Basically our muscle, which is the biceps, starts right over here and attaches right over here. So when the bicep does its contraction, what it does, that it will actually pull the load as such. Yes, so if you see, the fulcrum is over here, the effort or the force applied is right in the middle, and the load is at the other end. So this is the type 3 lever or class 3 lever. So you can see with a small motion over here, imagine that this point over here at the insertion of the bicep moved by 1 centimeter, actually the load moved much more because it's at a very long lever arm. This is how most of our human movement is done. Small contraction on the muscle creates bigger motion. Obviously, if we count the mechanical efficiency of this lever, it is not great because the force is applied over a very short movement arm, and the load is having a very big movement arm. In this case, the muscle contraction that we need to do needs to be strong in order for us to move a smaller weight. So this is the last model that I'm going to show you today. It also mimics a deadlift, but I revised the model a little bit. We learned just now that the deadlift hip extension is actually a class 1 lever because some of the hip extensors origins at the ischial tuberosity, attaches at the femur, tibia and fibula. But actually there's one more big muscle group that we didn't mention just now, which is the glutes. I'm trying to use a different rubber band. The pink rubber band is the glutes. The glutes actually origins at the upper part of the hip bone, right? And then it attaches at the femur. So because this is the center of rotation, the origins is above the fulcrum on the same side of the load. This deadlift, this hip extension are both class 1 lever and also class 3 lever. So that's all 3 classes of lever. I hope you find it interesting. In the next video, I'm also going to create this kind of model to explain about the function of the lats in a deadlift. See you next time. Just try to